Let's look at another example over here. It is given to us that there is a sphere of weight 1000 newtons, okay, and it rests against a block as shown in the diagram. So this sphere, which is of weight 1000 newtons and radius 30 centimeter, is resting against a block of height 15 centimeter, okay. We are supposed to find out the horizontal force required, which is this force, at the instant when the sphere is just about to roll over this block, okay. So just analyze this sphere. If you are going to analyze this sphere, you are going to get an FBD something like this, okay. Let us see what is happening. We have a reaction due to this particular block, okay. We do not know the direction. We have a reaction due to this surface, okay. We have the weight of the sphere which is acting downwards, okay, and we have the force which we have to find out, okay. So over here I have the FBD which looks like this: the force, the reaction of an unknown direction, the reaction due to surface vertically upwards, and this weight vertically downwards. The direction is known, the direction is known, the direction is known. Over here the direction is not known, okay. The question asks us to find the force at the instant when the sphere is about to roll over the block. When the sphere just about to roll over this particular block, it momentarily lifts off the ground, okay. At that instant it loses contact with the ground, right? So we are going to just say that when sphere rolls over block, it loses contact with the surface, okay. It loses contact with the surface, okay. Now since it has lost contact with the surface, it has just lifted off the ground, your reaction due to the surface becomes 0, okay. Therefore at that instant, therefore I am going to say at that instant my RB is going to be 0, okay. My RB vector is going to be 0, or the reaction due to the surface is going to be 0. Therefore now I take this off and I have this particular, let me just copy this. So I have taken RB off and my problem basically resolves to this. I have to find out the force F when the other forces are acting over this sphere like this, okay. Obviously what do I have? I have RCY, RCX, okay, and I have an F. So I have three unknowns. I have three equations: Rx is equal to 0, Ry equal to 0, and Mr is equal to 0. So easily I can find out the F, the RCY and the RCX. Let us find them out. So we know that first we always apply Mr is equal to 0 because this thing gives me a solution for one of the unknowns, okay, generally. So over here, at what point should we apply this condition? Over here or over here, okay, or over here? At any of these 3 points, one of the forces moment is going to be 0. We have to find out which point we should take. If we take this point, we are going to get an expression with F and RC, okay. If we apply at this point, we are going to get an expression with RC and this 100 newtons, so we would be able to find out RC, okay. And if we apply at this point, we are going to get an expression with F equating something to 1000 newtons, so we would be able to find